In this question, we have a relatively complex context. We have nuclear decay. But despite what it says, it's really our familiar friend of momentum conservation. So previously, we have this particle that just sits here. It has zero velocity, meaning it also has zero momentum. And then somehow it radioactively decayed into two different particles. One is alpha particle. You don't have to know what alpha particle is. It is pretty much just a helium atom, but you really don't need to know that. All you need to know is that it becomes two different particles. And since the original momentum is zero, and then due to our momentum conservation, its momentum must also be zero afterwards. So that also means that they have to be moving in opposite direction, because that's the only way the addition of the two momentum could be zero. So let's just call the alpha particle A and call this other particle B. Then we have MA, VA, MB, VB. These are just the quantities we will usually use. And let's try to write down the initial and final momentum. We have initial momentum is zero because it's not moving at all. Final momentum is MAVA plus MBVB. Great, so that is the equation we need. And our purpose is to find out the velocity of this other particle. We need to find VB. So that is our goal. So pretty much we need to know what MA, VA, and MB are in order to find VB. So let's look at what we're given. We're told that VA is 2.8 times 10 to the 5 meter per second. That's a huge number, by the way. But the question does not tell us what are the mass of the particles. All we know is that MB is 57 MA. That may not look sufficient, but if you look at this, if we can express MB in terms of MA, then we'll have MA here and MA here. And it's just zero here, so we can divide the whole equation by MA, so we will actually be able to cancel MA. But let's first try to do it. MB equals 57 MA. So if we plug that in, we have MAVA plus 57 MAVB. So that's great. Now we can cancel MA. We can divide the whole thing by MA. 0 divided by MA is still 0. And these two, we just get rid of the MA. So that then gives us VA plus 57 VB equals 0. Or VB equals negative VA over 57. And now we can just plug in the numbers. 2.5 times 10 to the 5 meters per second over 57. So that gives us roughly negative 4,900 meter per second. And again, this negative sign means that it's moving in the opposite direction as alpha particle, as it has to be. So that is the velocity of that particle.